Alrighty, this is your homework assignment for transformations of parent functions, which is the last lesson before our test. We're going to graph parent functions and the transformations and explain what happened. Also, we're going to include the domain and the range on the new graph. Number one tells us the function has an equation f of x equals x. The transformation has an equation g of x equals x plus 3. It says classify this function. So this function is a member of the linear family. Okay. So let's get our graphing calculators and let's graph both functions. So let's clear this function out, and I'm just going to put x for mama. Clear this out. Again, I need to darken my line. And let's graph x plus 3. There's mama, and there's baby. Let's pull up our table and get some good points to use so we can graph. So let's put mama in black. With red points. Alright, so mama goes through the origin. 1, 1, 2, 2. If I scroll upwards, she has negative 1, 1. So now let's just draw a straight line with a ruler through these points. And arrows. Now let's look at babies. When x is 0, baby is at 3. At 1, baby's at 4. At negative 1, baby's at 2. So now we can put a line through her. That's not a good idea. So this is baby. So if you look at the origin point, it shifted up 3 units. So vertical shift up 3 units. The domain is still negative infinity to infinity. The range is still negative infinity to infinity. All right. Number 3, f of x is equal to absolute value of x. G of x is equal to negative absolute value of x. So this is the absolute value family. All right. And now let's graph both of these functions. Under math, num, there's absolute. That's one way to get there. There's different ways, trust me. So x, close your parentheses. For this one, we're going to put negative absolute value of x. So let's graph these. That's mama, that's baby. So mama flipped over or did a headstand. So let's pull up the table and find some solid points we can use to help us plot. So we have the origin, 0, 0. We have 2, 2, and negative 2, 2 from mom. For baby, it's still the origin, but at positive 2, it's negative 2. At negative 2, it's also negative 2. So again, remember you gotta look at y2 for the baby y's. So we would say it was a reflection across the x-axis. In other words, baby flipped across the x-axis. The domain is still the same as mama because all x's are fair game, so negative infinity to positive infinity. However, the range has flipped over. The lowest possible y is negative infinity because it has arrows and it's constantly going downwards. But now the highest possible y is 0. And that gets a bracket because it's a definite closed point on the graph. Number 5 says f of x equals x squared, g of x equals negative 3x squared. So these are members of the quadratic family because it's a power of 2. I think I spelled that wrong. Oops, oops. All right, let's graph in our calculators both functions. So we do x squared for mama and negative 3x squared for baby. Graph. There's mama u and there's baby u. Baby looks a little thinner and he flipped across on it. He flipped upside down. Let's pull up the table for points to use in our plot. So mama is 0, 0. We have 2, 4, negative 2, 4. So that's mama. And then do your best to give it a nice U shape. And then baby still has 0, 0. At 1, it's negative 3. At 2, it's negative 12, somewhere far off the page. And at negative 1, it's negative 3. I guess I could have showed you how those correlated with mama. So for mama, 1 was 1. So you should see that it's kind of a stretch up, where it takes a lot longer to hit those points than it did on the previous one. So that there was a vertical stretch by a factor of 3, and a reflection about the x-axis. The domain is the same, negative infinity to positive infinity. The range is from negative infinity to 0. For 7 through 10, they want us to predict the movement based off of the equation and based off of what we've done in the past. So there's not really a way to graph these unless you use just one particular function to manipulate. It's based on, again, all the practice that we've done in class, as well as all the rest of the problems on this sheet. You should be able to make some conclusions and some predictions. Very simply, we know that when we have a -1 outside parentheses, that's a vertical change, and that's a vertical shift down 1. Now, a moment ago, we had negative signs on number 5 and number 3. But if you look at on number 3, the negative sign is not inside the bars of the absolute value sign. And for number 5, it's not inside parentheses for the x squared function. But on number 7, it is inside. So that should tell you it's not going to be the same type of effect. It's going to be similar, but not exactly the same. So the negative is going to bring on a reflection, but for number 3 and number 5, it reflected across the x-axis. So when the negative sign is inside parentheses or inside whatever grouping symbol it is, whether that's absolute or square root, that's a reflection about the y-axis. When it's inside the grouping, it is a reflection about the y-axis. All right. When we look at number 9, we have a +5 all the way out here. Again, that +5 is a vertical shift. Up 5. And then we see a 1/3 inside parentheses. Remember, I told you if it's inside parentheses, it's lying to you. The parentheses are lying to you. So it's on paper saying 1/3 x. In other words, we want a third of x. We want to take x and divide it by 3. But we said parentheses lie, so do the opposite. So that means your x values are going to triple. So that means the x values are going to get bigger, causing it to be the graph to appear wider. So this is a horizontal stretch. Yeah. By 3. We did a vertical stretch by 3. The 3 was outside, literally outside in front, telling you to multiply by 3. But this one, you got to do the opposite of 1/3, which is multiply by 3. And that's a horizontal, since it's inside, it's horizontal, and it's a stretch by 3. I hope this helps you be able to complete the rest of your assignment. Good luck.